Hey, and welcome to the Collective VC podcast. Today we're joined by Rich Walker. I bumped into Rich at the UK Innovation Network. He is a director of Shadow Robot. So, Rich, if you could introduce yourself and Shadow Robot a little bit better, more concisely, more informatively for our
Sure.
listeners, that'd be great.
Thanks for that, Oliver. Great to do this today. So I'm one of the directors at Shadow. I used to be the managing director. I did 14 years as that job. And we're a robotics technology development firm. We make the best hands for robots in the world. We sell those all over to people who do R&D and development in robotics. So we have an amazing client list, but everybody there is doing pretty much doing research in what can be done. Over the last couple of years, we've started to move into a more technology delivery oriented, I could say, in that we now work with a few people saying, okay, you want technology like this, let's help you build it out in a more solid way in your organization. So understand what can be done, understand how it can be done, understand what the possibilities are of future hardware, and maybe build some of that future hardware. So on the one hand, we sell product to people doing state-of-the-art research. On the other hand, we provide a kind of engineering service helping people build out technology in the robotic manipulation, hands for robots arena.
Okay, cool. And when people hear hands, just to make things clear, you guys aren't in prosthetics or anything like that. You're solely focused on sort of how robots interface with the world via gripping and moving and holding.
Exactly. It's prosthetics is a kind of a different spin on how you design things. If you look at a kind of typical prosthetic that we use a lot, say a pair of glasses, you'll notice that they're very lightweight, they're very flexible, they're pretty robust. They do one thing really, really well. I mean, unless you've got varifocals, in which case they try and do two things well, or reactor-like lenses, but pretty much they do one thing really, really well. And you can change them for style and fashion if you want. Whereas if you look at something like a camera or a telescope, which might be the robotic equivalent of a pair of glasses, that will tend to do a lot of things. It'll tend to be relatively bulky. It'll probably have batteries that need recharging. It'll certainly have lots and lots of fiddly options and switches and things you can do with it that change its settings and adapt it. And it sure as hell won't have a fashion version. So there are kind of two very different design spaces, and we've always stayed over in the robotic space rather than the prosthetic space. There's some excellent work going on in prosthetic design, and it's kind of like, yep, they're doing that. That's fantastic. We'll do this stuff over here.
Yeah, having to not get sidetracked and look at that.
Focus,
So yeah,
focus.
so why don't you give a rundown on the background of Shadow Robot? Where did it begin? At what point did you get involved? What sort of getting to know the team looked like?
Sure. We started out as a team of people who basically built robots for fun. We met through one guy in Islington who was embarking on a quest to build interesting and useful robots by himself. Totally self-taught. His background is a photographer. He wasn't associated with any university, and he used to get quite angry when people said, "So, which university are you from?" I'm not. I'm not. And we were essentially almost a kind of somewhere in the nexus of what you might consider a hobbyist club or a hack space or something like that. And he was well enough off to kind of have a space and fill it with tools and equipment and things we could work on and do. So there was quite a few of us gathered around that. And at some point in the late 90s, we started to get offered engineering work where people would say, "Could you build something for me?" And we're like, "Yeah, sure." And they were willing to pay us for it, but they needed us to have a company to do that. So
Mm.
once we had a company, we were like, "Oh, right, what do we do with the company that we couldn't do with previously?" Treat it as another tool, another piece of the jigsaw. Now, at that point, there wasn't really an investment community in the UK around hardware for computer robots, the technology hardware at all. I remember we did go and talk to one investment firm, and they were like, "Oh, we don't invest in software." And we were like, "We don't do software. We actually build robot hands." And they were like, "No, clearly this is a simulation. No one's doing this." And we're like,
That's funny.
yeah, but we did get some R&D funding. We got some from an early SMART award from the government. We got some invention and innovation funding from Nesta back when they were doing that kind of thing, and that helped us develop these robot hands. And then we had some universities come to us and say, "These are amazing. Can we buy one?" And that progresses into that space of selling robot hands. So then, for quite a long time, we did all sorts of things in robotics. We built leg robots, we built special actuators, we built arms, we built some giant tentacly things with some theatre people that people could dance with. That was a fun project. And we carried on selling robot hands to people and getting involved in the tech development community. And then about 7 or 8 years ago, we realized that we were probably missing a trick by not focusing. We started, I mean, I've always been a reader of business books. I have a long list of ones I'd recommend, but we eventually got most of the company to read Jim Collins' book, Good to Great. And that really resonated with us, partly because it fit very much the way we think about operating as a team, and partly because the idea that you work out what it is that you do uniquely and you're the best in the world at it, and that's what you do, and then people obviously come to you because you're the best people for doing it. Why wouldn't you go to those guys? But then that also means you have to learn to say no to all the things that you'll just be average at. Or engineers.
Right.
An engineer can do a lot of different things, but they can only do it as well as any other engineer could do that. Whereas if you're an absolute specialist, someone referred to the phrase boutique engineering once, and I really took that because that's exactly what we are. There used to be a boutique shop on Upper Street in Islington that only basically sold black dresses. That's what they did. If you wanted a black dress, you went there. If you want anything else, don't go to them. And we're kind of like that, but with robot hands. You want a robot hand, you come to us. You want something
Yeah.
else, we'll tell you other people who can do it, and we'll probably do an introduction. And a lot of the time, this is what happens. People come to us and talk to us and say, well, yeah, I want to do this. And we're like, yeah, have you met Xco? No? Okay, let me do you an intro because Xco do that, and they'll do it cheaper, faster, and better than we will because it's their bread and butter.
Yeah, you don't even,
When you
why
need
attempt it?
Exactly. When you need a really dexterous robot hand, come back to us. And then you can see the look in their eyes when they come back. Okay, I need a robot hand. Let's work with you guys. Because, it's then the right people and you're the right people and everything is a really good fit at that point.
And I imagine that specialized network effect comes right back the other way as well, because everybody knows you're the robot hand guys, right? So the amount of referrals you send is probably the amount you
Yeah.
get.
I mean, ChatGPT knows we're the robot hand guys. Our referral
Wow.
network is that bad. There's so much out there in the literature that says, oh, yeah, robot hands, go and talk to Shadow, that if you ask ChatGPT about robot hands, it says, yeah, go and talk to Shadow. Save yourself
Was
lots
that
of
before ChatGPT got access to the internet? When it had its 2021 cutoff, or is it even
Oh,
after?
yeah, it was definitely
I have to
no,
check
because
that
we
out
have
after the.
we go way back. I mean, there's Wikipedia pages that are ancient that are about our robots. There's articles from the early 2000s about our stuff. So we really have that kind of. I mean, it's one of those things that people say, when should you start promoting what you do? And the obvious answer is 20 years ago. But if you can't start 20 years ago, start now. But really,
Start
ideally,
today,
start
yeah.
promoting what you do 20 years ago, and then mysteriously everyone will know who you are and what you do.
So when exactly was it that you decided to specialize on robots and on hands and dump everything?
It was I've just been reminded of Ernest Hemingway's line about going bankrupt. You go bankrupt gradually and then suddenly.
Yeah.
And it was kind of exactly like that. It was gradual. We realized that we were doing other projects and they just weren't any fun. They were hard work, they were low paying, they were unrewarding, and there was no benefit to us for having finished them or having got to, we'd do it and it'd be like, done that. And everybody would be like, thank God that's gone. Let's not do that again. But then the projects where we were very successful and we were having a good time doing it and our customers were having a good time working with us, which is kind of quite important to us, were all the ones around hands and robot hands. So it was a gradual shift, and then suddenly we was like, what, we should just stop doing the other stuff. We should just turn it away. We should take a policy of like, actually, we just do this bit. So I'd say really the shift happened probably between 2015 and 2020.
Okay, cool. So I guess, was there any sort of understanding of the use cases there that really led that shift as well? Were you thinking like, okay, how is this a really crucial product to be built? What sort of challenges need addressing now? But also, what's potentially the market unlock in the future? How are our hands going to be used in the future? Because I imagine it's quite a big decision just to like solely focus on one product from an idea of, okay, well, how is this going to be used not just now but in 10 years? So is this business going to still be relevant?
There's an element of it was less focusing on one product as focusing on one place in the landscape, which we kind of see it as like, people do these analogies around like, are you defending a mountain pass or whatever? And we're like, well, we live up a little mountain. We live up the mountain of robot dexterity, and we live right at the top with the most dexterous robot hands. And other people live further down the mountain. You can go to someone like Shunk and get all kinds of lovely hardware for production operations where you want to grab hold of things and keep hold of them. Fantastic. Robotic, great grippers for industrial robots if you want to grab something and hold it. But when you want to do fine manipulation, human-like tasks, we are the people in that space, and we know how to build that hardware and how to get it to do things. The challenge we always knew was that there weren't many use cases until the software was there. And that's kind of always been the issue with robots. A good mechanical engineer can build a good robot, but unless there's a really good load of software behind it, that good robot isn't much use to anybody. It's just a thing that can make some movements. And that's, in the last few years, there's been a definite change there. A lot of the tools that have come out of deep learning have suddenly shifted the needle quite a lot in terms of what people can get robot hands like ours to do. But now we're lucky enough that over the last 20 years, we've had all sorts of people walk in the door and go, I have a problem that needs robot hands, I think. And we go, yeah, you do. But the technology isn't ready for you, for whatever reason. And we've kind of got a Rolodex effectively that we can go back and go, well, what about that problem? Okay, actually, it's worth going and talking to people who have that problem now, because we know what's advanced in the other areas around us, and we know where our hardware is. And so there's an opportunity to go back and say, hey, you guys said you had a problem with handling things like this in these circumstances. Well, we think this has changed and this has changed. So I think it's worth having another.
So your pipeline pretty much one-to-one correlates with how you foresee advancement in the space.
It's pretty much, there's a very obvious chain of use cases out there that as the software for robots gets better, then the hardware becomes useful. And the nice thing is, we've worked with all the people who do the software as well. Mostly they've been customers for us, our customers, because they wanted hardware to do their research and they've needed the state-of-the-art hardware.
So could we talk actual use cases of a hand and specifically link it to dexterity? Because when I hear dexterity, I've only ever really linked it to my own understanding, which is when I had a cycling accident a couple of years ago. I really lost all of the dexterity in my hand, and I was suddenly seeing this word everywhere in all of the NHS pamphlets. It's like, you need to regain the dexterity in your hand. And I'd never really thought that a hand was something that, everyone just has a dexterous hand. They don't think about what actually constitutes a dexterity. So yeah, maybe just talk us through what that means to you, especially as somebody in robotics. I'm sure your understanding is a lot more advanced than ours.
It's a really good question, actually, and it goes right to the heart of one of the fundamental problems that we have in robotics, which is we have no way of measuring dexterity. We keep talking to people about this and we go, have you worked out a way to put a number on this? And everyone's like, no, not really. We sort of use this benchmark here, and yeah, but that doesn't cover this. And a friend of mine said, I can tell that you're the experts in this because you're the people who know the most about why there isn't an answer to that question. It's like there's lots and lots of reasons why it's complicated. But put very simply, we devote a huge amount of our brain to controlling and operating and sensing our hands. A huge amount of the nervous system works on that. And there's a huge number of muscles and joints and movements in there. And that's expensive. That's really, really expensive. From an evolutionary perspective, there's got to be a big advantage to running that for so long and so much complexity. So there's obviously a benefit from a kind of species level function. And then there's the other point, which is that as humans, we design our entire environment for us to use. And we're expecting, for the most part, that we're going to use our hands to do that. So if you're thinking about working in a human environment, you're thinking about having human-like hands to do tasks. You'll see robots manage to not have human-like hands and do things in a human-like environment, but they can't do all the things. And the things they do are often quite clumsy and potentially quite harmful to the things they're working with because they don't have that level of ability to very precisely control how they're interacting with it. And so the part of dexterity is that precisely controlling how you're interacting. I can place my fingers in different places on something, and then by shifting my thumb around, I can change the movement of it very quickly. So something like twiddling a pen in my fingers. That's a very precise control of the pen. I'm not moving my arm, my wrist to move that pen. I'm just moving 3 fingers. And then I can twiddle it round, flip it, turn it, and so on. That doesn't necessarily seem like a useful thing to do, but then if I take another household object, pair of scissors, to operate a pair of scissors, I've got 3 or 4 fingers interacting with those scissors in different places, and I'm doing quite skilled application of forces, and I'm making really interesting movements because the scissors are rotating around a joint there, and if I'm cutting something, and I'm probably actually feeling the cutting action because I've got such good sensitivity in my fingertips. So
that was going to be my next question.
Yeah, that's
sorry.
That's kind of the space we're thinking about. It's how can we apply forces to things in multiple places at the same time and then vary the directions of those forces at the points of contact? How can we slide across things in the way that we can shift from one place to another on the object so we can do that force application? And yeah, none of us yet know how to measure it in a way that makes any useful sense to anybody.
And I guess it's also sensing those forces. I mean, through the hand that's actually delivering the force as well.
Exactly. Another thing that the human body does really, really well is to embed sensors into the skin. There are 8 different types of sensors in your skin for touch, 4 on hairy regions of your skin and 4 on the smooth regions of your skin. They're different for some reason. And those sensors measure very different things. There's one that responds to a particular frequency that we think is about the frequency that happens when you start slipping because of the shape of your fingerprint.
Right.
That produces a certain vibration, and that sensor is optimized for that. Cool. So when we try and build a robot to do something, we start with the simplest possible way of doing it, because as engineers, that's always a good idea. So you think, okay, I've got a contact point. I want to measure the forces on that. I'll put a force sensor there, and that will give me the force indication. And it does, but it only gives you one force from what might be a complicated contact. It doesn't tell you where that contact is. So you go back and you think, well, maybe what I want to do is to put an array of sensing tools of some sort across the surface and have that measure things. And then you say, well, okay, but how do I make that array? And how do I make the electronics to read it out? And how do I pack that into the finger? And how do I make the surface durable enough to survive? Contact is abrasion. So when you rub something with your finger, you're trying to wear your finger surface. And you will wear your finger surface slightly. But fortunately, the human skin regrows. There are people looking at how can you build skins that regrow for robots, but so far that hasn't got that. There's some work. It's interesting. We did nearly use it on a project once, but it would have been like, yeah, does this stuff die as well? And they were like, oh yeah. Probably not there. Not ideal. It's a hard problem. It's a really hard material science problem to build things with that can be worn and be soft and can be managed. And typically what you end up doing is saying, yeah, those things will wear out and you'll have to replace them because they are wearable parts.
So how did you guys solve that array problem? Was it just creating like a really, really fine array with lots of different sort of contact points?
We did. It's often the case that the answer to that is we did several things. One is we outsourced the problem. So other people build fingertips for our robots, which is nice. And they come with their own technology approaches and design approaches and develop those. And essentially it's quite modular, so you can just replace the fingertip with a different one, and that can give you a sensing capability. And then in some of our other designs, we went through and we said, okay, what are the best techniques we know of for measuring contact and location, and then what are the ones that we can really work with and put in. And on our newest hardware, what we have is one type of sensor which actually uses a lot of little magnets. So it turns out it's very easy to measure the location of a magnet with respect to a specific type of sensor, a Hall effect sensor. And these are used for all kinds of industrial purposes. So there are lots of tiny chips that just do that measurement. So it's actually quite easy to put a load of those across the finger surface, and they all communicate quite nicely, and so they're fairly easy to read out. So that's one strategy. And then the other approach we've been using recently is actually optical. So on our new hand, we put 2 cameras inside the fingertip looking at the inside of the finger. And that gives a really impressive response to contact locations and touch. That's now a technique that's used quite a lot in robotics, fingertips with cameras in them. Meta have just released a new Digit 360 sensor, which there's a whole bunch of stuff about on the internet, because that does something similar. It uses a camera looking up at the inside of the fingertip.
So does that have to be in well-lit environments if the light is sort of changing from the outside of the finger?
There seem to be 2 approaches to this. Some people have a well-lit fingertip and it kind of glows like ET, which is slightly unnerving. What we do is we hide all the lighting inside, so our fingertip is opaque and it's lit on the inside with, curiously enough, a red LED. You can't tell from the pictures because the pictures are all black and white, but we use a monochromatic light source in there, basically because we've got very, very strong lenses. And if we had any other color in there, we'd get chromatic aberration. which is a pain. So we have a single color of light illuminating the fingertip. And ideally, we shine lights at it from outside and we can't see those.
And what sort of size and resolution does one of those cameras have to be inside a digit?
The ones we're using are a 640 by 480, so not super high res. I mean, a crappy webcam, basically. And they are incredibly small. The modern camera phone has driven camera development so far down the line that we actually find ourselves looking and going like, where's the camera chip? We put it down somewhere. We put it down on the table. Where do we put it down? You know, because these things are just really, really small because there's been a huge amount of work to get them to. So you get very, very high resolution arrays and put those in nice little neat packages with sensible interconnects.
And did you have to write the software to sort of understand the depth of the sort of video feed that you're getting and at what point and where that correlates onto the inside of the finger?
Well, the nice thing about that fingertip was it was actually developed in the project for Google DeepMind. And we said, do you want us to process this information? They said, oh, no. We'll just feed it into our giant neural networks and they will learn to process the information. We were like, oh, great. Thank you. Because that's quite a challenge processing that information. Yeah. So we're looking forward to seeing what people do with it. Classically, it's a stereo camera pair looking at a dot pattern that's a predefined dot pattern. So it's fairly obvious what you do in terms of computer vision to turn that into a model of the shape of the inside of the finger. That's a kind of fairly standard piece of computer vision work. It's just we haven't done that yet because we haven't needed to.
Cool. I mean, yeah, back to your example of, say, manipulating something with a hand, twiddling it about. I mean, if you ask a human to do that for 10 hours, they're going to drop it a few times, right? So how do you sort of measure what is acceptable for a robot? What's the acceptable outcome? And then, as a follow-up, how does that sort of influence the R&D timeline of a particular product? At what point do you know it's finished, right? Because I feel like perfection, everyone has their own definition.
Engineers love to spend forever optimizing something that doesn't need optimizing anymore because it's good enough, or indeed, when you go and market test it, actually you find that there's no point optimizing it anymore because the market wants something different. And the extra time you'd spend qualifying this thing would just be wasted. We've seen that a lot. It's a very well-known problem in engineering, or rather, it's a very well-known problem in product design. Engineers don't see it as a problem much. But from the point of view of, what you're talking about is measuring the performance of a robot doing a task. And again, this is actually something people aren't very good at doing. You find that people will, in production environments, if you're running a production line, people will know what level of performance they need because they have some fairly hard reliability aims to meet. If you're running on a 52-second takt time, then the robot has to complete its task in 52 seconds. If it takes 100 seconds to complete the task, you have to have two of them and alternate one and then the other. Sure, you can do that. If it takes 20 seconds to do the task, but it fails one time in 1,000, as long as it doesn't fail catastrophically, and you can repeat the task and have it work the second time, then that's fine because the whole task can be completed in the 52 seconds. So a lot of it is about working out what's acceptable and what's not and what you do when you fail. But yeah, you will see a huge number of robot demos where the robot does something, and then when you ask the question, so can it do that 100 times in a row? The answer will be, maybe. And when you say, well, can we get 4 nines, please? 99.99% reliability. People are like, oh, that'll take a long time. It's like, yeah, but that's what you need to actually do a kind of a reliable deployment on something like a production facility. And that process of effectively benchmarking robots doing tasks is something we aren't as good at in the robotics community as we should be. We spend a lot of time talking about benchmarks, and everyone has their own favorite benchmark, which isn't that helpful because that means you can't really compare results.
Yeah, well, I guess it's just where, the academic side of it and the business side of it meet is, how well can these things actually do the task they're required to do and not just be a shiny demo? Because I don't know if it's robotics in particular, well, any demo really, there's always a way to make something look good, I think. Wasn't you all know the answer to this? The recent humanoid robot Elon Musk demo, turns out, wasn't it just somebody actually performing in the background, and they were linked to the robot itself. So everyone thought, oh, a robot's pouring me a drink, but it's a bartender in a warehouse somewhere in a suit.
Yeah, and teleoperation is is both a good thing and a bad thing in robotics. It means that you can use robot hardware that you can't write software for, or you wouldn't write software for it. So typically teleoperation gets used a lot in very safety critical environments where you can
Mm,
say, we absolutely know what the robot is doing because Jim is controlling everything about the robot. The robot is not doing anything Jim does not tell the robot to do, and therefore we can be confident that we can do this task. So, for example, people in nuclear do this a lot. Teleoperation is also good for teaching. You can say, I will show you how to do this task, and then now you have some piece of knowledge about it. And you'll see there's a lot of work going on at the moment where people are essentially setting up little farms of robots and having a whole load of people operating those robots to teach them to do tasks. And then they're capturing that data and they're using that to feed into learning systems that they expect will learn to do more tasks and more generally do tasks.
mm, mm. I was just thinking, I had a little memory there. The first instance of tele operation that I encountered in my life was that film Real Steel from from ages ago, where the kid adopts a futuristic robot and his dad is an ex pro boxer and he was literally shadow boxing with the robot and they won a tournament. So I just it's a funny little flashback there. No, it's a good movie. You should watch it. So yeah, I guess let's talk about some of the use cases of the dexterous hands. Where are they right now in the world? Which ones are you most proud of? Are they on industrial production lines? Yeah, just run us through that.
So basically what we're doing is we're making an enabling technology at the moment. People are using it to work out what to do. So typically, I don't think anybody has ever deployed any of our hardware in production, but what they have done is they have used our hardware to work out how to do something, or done something for the first time. So a
Mm.
few years ago, a guy came in the door and said he wanted to make a robot kitchen. He used our hardware to build the first version of the robot kitchen, what we did, and that was done really, really quickly. And we made a really nice piece of work. He got a fantastic demo out of it. He was able to show that at trade shows and so on, and therefore raise the investment money he needed to build a real robot kitchen. Cool, excellent. He's not using our hardware for the real robot kitchen because it's not designed for that. You need the thing then that's designed for that. So that's kind of where we sit in the landscape. We're building things at TRL 5, 6, and then people are building something else for TRL 7, 8. That said, we currently have someone who technically is in production with our hardware. It's a little bit of a stretch, but essentially the new robot hand that we built for Google DeepMind, they're using at scale as a platform for doing robot learning, which formally qualifies it as like it's in production there. It's a very weird market because obviously what's the market? It's people who like Google DeepMind doing robot learning. Okay. But on the other hand, it's a market niche. It does exist. It's a sector that we can define.
So correct me if I'm wrong, but I feel like you guys, if I was working at Shadow right now, my sort of outlook would be okay. Everybody's trying to build computer systems that understand the world and are intelligent and can make decisions. So the way that we, can link a computer to the real world is giving it a means to interact with it. I feel like that's hands. So how are you preparing for? I mean, the current. I don't want to call it like a boom, but I guess just a much more focus on making computers interact with the world. Are you experiencing that? And yeah, what's that preparation?
I mean, honestly, it's very exciting. The wave of humanoids that have popped up in the last couple of years has been fantastic because what we've seen is that the technology of building a humanoid robot has been around for a long time. I mean, the first ones that I recall seeing that were anything like 20, 30, 40 years ago. But it's now got to the point where it's not a fundamental research project to build one humanoid robot. It's an engineering process to build an operation that builds out robots at scale. And you can reliably get them to behave and to walk and stand up and to do things. So that's a really nice shift. It means that there's a new platform available for using. If you remember when Boston Dynamics produced the robot dog Spot, what happened there was SoftBank basically said, look, this is a really interesting thing. What would it take to make it a standard platform that everybody used? And the Boston Dynamics guys said, oh, well, we'll have to do all this work, all this development, all this testing, there'll be really loads and loads. And SoftBank said, great, let's do it. And so they built out a way to deliver Spot at scale as a standard platform that people used. And it's now really widely used. And every so often I go somewhere and there's someone says, oh, yeah, of course, we've got a couple of robot dogs. We use them for, and you're like, okay. traditional hard hat industries where people are very, very serious about safety and they spend a long time planning things and they spend a long time checking things are okay, they've probably got some robot dogs now. And those robot dogs are doing some of that work. They're climbing around production sites. They're going into dirty, dark corners and shining a light and having a look and coming back with some video. And everyone goes, right, now we know what's around there. We didn't have to send a person down there. We didn't have to work out if we needed to put breathing apparatus on the person. We didn't have to have a buddy waiting. So there's a lot of cases where the platform has meant that suddenly the technology is getting used in ways we wouldn't have thought of 10, 20 years ago. And I think we'll see that with humanoids. There's now lots of platforms. Therefore, people will try all kinds of interesting use cases. And some of those use cases will work. And then they'll say, OK, we know we can do this. Now, how do we do it better? And what technology do we need to do that better? And maybe some of that technology will be manipulation and dexterity, at which point we're well placed to be the people they come and talk to and say, hey, can you help us make this robot more dexterous? Because it isn't dexterous enough at the moment. It may equally be that the problem they've got can be solved with a robot like that, and it's like fantastic. We don't need to talk to them.
So the durability is also a factor, right? I think you mentioned in the talk I saw you deliver about the collision problem in robotics, and that being a reason why sort of repetitiveness could destroy something. So I guess balancing durability and dexterity, we touched a little bit on it earlier, but I can see that being very frustrating to work on.
It's classically something. I mean, if you talk to anybody who works in research in robotics and you ask them how many of their robots are broken at the moment, they'll look pained, and they might answer, and they might not answer. And we've all got horror stories of the night before a big demo, something breaking, and you having to repair the robot so that happens. And the reason it happens is because we're typically using the robot outside the well-specified, well-designed area it was set up for. If you're using an industrial robot arm and you're trying to cook in a kitchen, they didn't think of that. There's a whole bunch of things you're doing that they didn't think about, and those will then become problems. And you may or may not understand those problems well enough to get around them, or you may have to deal with them, or you may have to change the system so it can cope with that. What we found with the robot hand was, because the human hand is such a fine piece of engineering, right? It was actually really hard to make something in the same form factor that was robust. You don't have space, right? There's literally not enough space in there to put big, thick chunks of steel. So you have something that is going to be coming into contact, because when I reach out and grasp something, right, what I do is I'm touching it, I'm scrabbling on it, I'm feeling it, I'm contacting it. And that puts forces on it that are not necessarily the forces it was expecting in some ways, particularly if I move my arm while I'm doing that, I can put quite a lot of force on my fingers that they weren't expecting. So we have to think about that kind of contact and that kind of interaction. And on very dexterous hands, it's a real problem. The robot that we built for DeepMind was designed from the ground up, assuming that was going to be what its day was spent doing. It's going to be banging into tables. It's going to be grabbing objects in funny ways. It's going to be crashing into things. It's going to be learning to do something and therefore doing it badly at the beginning, possibly even stupidly. So we built it with that assumption, and we spent essentially the only way to do this is to test things. So we did a huge amount of work testing all the components and testing all the systems, and we've got days and weeks and months of recordings of just like hitting robots with pistons and having things grind into each other, and a few hours of people hitting them with hammers, because that was kind of the final test. Can you hit it with a hammer? Yeah, great, that's fine, it's probably okay. I mean, you can hit yourself with a hammer, you won't enjoy it, but unless you do it really hard on a surface, it won't break you. This was pretty similar. It's like, the robot should survive that. It might not like it, but it should survive it.
Yeah, and obviously this is where the pain is, the natural equivalent of this. It's like we understand what causes us damage, and I think going back to your cooking example, it's like, how many times has you've been boiling something and you haven't quite noticed it's boiled, but because your hands reacted to the steam, you've then been aware that it's now hot and you don't want to hurt yourself there. So it's like, all of these different things that you wouldn't really initially take into account.
And I think there's something really interesting there about how in developmental psychology, as you learn to do things as a very, very small person, pain is one of the ways you learn what you shouldn't be doing. When you fall over, you cry, right? Because you've hurt yourself, and it's a shock, and it's painful. You may not have damaged yourself very badly, but the shock causes you to be upset, and you kind of learn that kind of whatever you were doing, don't do it like that, or don't do that. So that comes in as a very kind of early learning thing. It's like you'll touch a hot stove once. You should then remember that, and because it'll become quite a low level thing that's like, oh yeah, that thing gets really hot and it's painful, and I don't want to do that. Robots don't really have the same learning tools and skills. We've tried that a bit, but it's actually quite hard to capture what would pain be for a robot idea, especially given that there's that kind of interestingly narrow boundary between, well, yeah, that might be painful, but that might actually also be what we want you to do.
Yeah, and I guess it's like, because like you said, as a child you learn about pain, and it happens over a very long period of time, that sort of repeat exposure, you become more accustomed to the sort of complexities of pain. Whereas because there is no real natural understanding of pain from a robot standpoint, there isn't really that sort of gauge of different levels of pain as well, right? I mean, unless you try and hard code every single little bit, like adding a temperature sensor to work out how much heat there is. I mean, how quickly a robot moves their hand away from something that you consider to be painful, that speed is going to be entirely unrelated to the amount of pain that would be felt, if that makes sense.
Yeah. So one of the methods that works very well at the moment for learning is a technique called reinforcement learning. And in reinforcement learning, what you do is you define a reward. And the reward is normally thought of as a positive. It's like, what does success look like? Okay, we'll score you on how well you're doing the thing. And then you'll try doing something, and we'll give you a reward score, and you'll use that reward score to improve what you were doing. And it's a nice mechanism. It works very well. There are some preconditions on it, like you have to be able to differentiate things, and you have to get the reward fairly evenly distributed across space so you can try stuff, but it's very doable. And when you look at people's reward functions, you find that a lot of the time they're quite complex definitions of what success and not success looks like. And you can code into that effectively, if you're doing it like this, that's bad for the robot, so we will penalize you on that part of it. But if you do it like this, that's good, and we'll increase your reward for that. And then the robot learning system will avoid the things that penalize it in the reward space. So
and then, so yeah, how does that play into the challenge you sort of briefly mentioned earlier about maybe at some point needing to go back and undo that learning, right? But is that learning then too integrated into the positive feedback as well? And so I guess
there's a whole learning science thing there, and people are now starting to think about curriculums for teaching robots. So taking a robot through a series of easy, medium, and hard tasks when it's learning to do something, and then maybe we'll show it a series of tasks at varying levels of difficulty, and what order do we do those in, and how do we interleave them, and this is an unusual thing, but is it a good example to show the robot? Will it learn more if we show it that unusual example?
So yeah, going back to sort of, I guess, feeding off from durability, but also what you mentioned before with robot dogs in disaster zones. My interest is in climate change, specifically, the adapting to the environments that we're going to face in the future. Do you see robots playing a more of a role than they do now in the harsher weather conditions and environments that we're going to see in the future? Yeah.
I think there's a lot of places where robots will be able to help that maybe aren't immediately obvious. I mean, I don't know if you've seen this figure, but apparently the most dangerous form of power generation is domestic rooftop solar, because more people fall off roofs installing it.
Yeah.
Even coal mining isn't quite as dangerous as that, and coal mining's pretty brutal. So that's exactly the case where you think, well, okay, why aren't we using machines to help with that? Partly it's because if you look at the UK, every roof is different, every house is different. There's no repeatability, there's no consistency there. So it is always a manual installation job. But I think there should still be some ways to add robotic type tools to make things simpler and easier there. And then there's jobs in maintenance and inspection. So every wind turbine gets inspected once or twice a year. That's if it's a wind turbine in a field, that's fine. Somebody drives over into the field, they they climb up the inside. Probably there's maybe even a lift inside it. They climb around the nacelle, they do some inspection. They have to inspect the blades, and so there's a bunch of people building robots that crawl along the blades of wind turbines and inspect them, and look at opportunities to repair them, because that's actually pretty important. When that wind turbine is in the middle of the North Sea, which is where the wind is, now you're on a boat. You're taking a boat out into the North Sea, somewhere that by definition is quite windy, and climbing up a 130-meter tower in the North Sea to do some work. Suddenly you're thinking, yeah, let's think about putting robots in those places. And hell, those towers were built with the idea that a human would go in them, so maybe that's the perfect place to use a humanoid robot, because we've already built it for a human.
And I mean, very tragically, I've seen some quite unpleasant footage of a maintenance worker actually stuck at the very top of a wind turbine, which caught fire, and he literally didn't have any way to descend because the fire was between him and the shaft. So, I mean, I never really thought of a situation where, I guess, I don't know. I think there are so many jobs in society that, because robotics haven't been at the level where they can be used for anything, we just kind of accept a necessary amount of human death or human suffering. And I think maybe as a society, in order to really put robots everywhere, we're just going to have to unlearn that and really recognize that we need to just focus on that more. Yeah, I think we have such a high quality of life nowadays, especially in the Western world and the global North, that accepting and identifying the trade-offs where they are, instead of just saying, okay, well, they're a necessity, and actually working to build those solutions and forcing people to pay for them. I think that's going to be a really important part of just sort of transition, especially with widespread electrification, where all of this stuff is going to become more widespread. So I think robots are definitely going to play more of a role.
Yeah, and a lot of it is, I mean, you kind of touched on a really interesting theme there, because a lot of the time we can push that bad things happen to make this possible a long way away. So it's been interesting looking at things like the work that's been done on conflict minerals. Essentially, you don't want your mobile phone to be responsible for anybody to have died to make it, right?
100%.
I don't want to buy a mobile phone that's got blood on it. And there are very good, very active processes that try and make sure that manufacturing supply chains don't have minerals that come from war zones. How successful they are is a good question. It's worth auditing, it's worth verifying those, and there are people who audit them and verify them. But the whole principle of eliminating conflict minerals from your supply chain, and we've had contracts from customers come in, and the contract explicitly states, we want to know that you've done a supply chain audit. And that we can say, yes, you as our supplier are not putting any conflict minerals into our products. Great, we say, but that's the kind of thing we want you as a customer to say, because then we all agree that that's the right thing to do. And with things like maintenance, inspection, and construction as well, there's always been a tendency to accept, it's a dangerous job. But it doesn't need to be. It shouldn't be a dangerous job. And there are ways to do those jobs safely. And if those ways to do those jobs safely start to include robots, then that will only be a good thing.
So you also mentioned before that you are a employee-owned organization. So maybe if you could walk through how that's impacted your work and potentially either strengthened you in some areas or even limited you in other areas, just feel free to let us know what that's like.
Yeah, so it's an interesting one, because when we started out, our cap table was never a well-organized thing. The guy who'd set up the hobbyist club owned a significant fraction, and then various other people had bits and pieces of shares, and at various points we'd kind of given out some more shares because some event had happened where it felt appropriate to give some people some shares, and it was all a bit of a mess. And we looked a bit at fundraising and investment, and it was clear that cap table wasn't going to work for that, but it hadn't really bothered us because we didn't go that far down the investment route at that point, partly because, to be blunt, we didn't have an investable proposition. What we do looks a lot more like a high-end consultancy lifestyle business than a scale this and take it to market and sell it to a PE firm in 5 years' time business. It's a different style of organization. So it wasn't obvious that we needed an investable cap table. And we eventually thought, well, why don't we actually fix this by saying, let's make sure that everybody who works here owns a piece of the organization. That seems to us to fit our values much better than a few people own it and everybody else works for it. So we looked into it, we set up an employee share scheme, and we're able to issue a bunch of shares straight away. And then we set up a 3-year options plan. So basically, everybody gets options on a rolling 3-year window. Those options vest. So if you join the company in January 2025, your options will vest in January 2028, and then your next options will vest in January 2029, and so on. We picked 3 years because 4 years felt like it was a bit too long to ask people to wait. But looking at kind of people who stayed at the company over the years, basically 3 years is pretty much the point where if they stay 3 years, they're going to stay for a long time. They fit, they find it's natural, they like it, they want to be there. It does mean that some things are not open to us. So we occasionally get offered business finance from people who are essentially offering a loan on some terms to the company. And we look at that and we go, so yeah, you need every single shareholder to agree to be on the loan. Yes, they say, okay, great. Here's our shareholder list. Oh, they say, yeah, that's going to be tough. That's going to be tough.
Mm.
And it means that there are certain things like that are more difficult. But I think on the other hand, if when we did it, it felt like the right thing to do, and it still does. Because what we're saying is, look, you work at Shadow, you've been part of the Shadow team for long enough that we're family. You should have a piece of this. You shouldn't be just somebody who's paid to be here. You should be a part owner. And of course, if there is ever a moment where an 800-pound gorilla comes in the room and says, "I'm buying you," then everybody benefits. Which is, it's important that that potential upside is there, but it's not there to give everybody a potential upside, if that makes sense.
I'm usually quite against people saying, corporations are a family. I think, but at the same time, in this instance, it feels like you're definitely on the way to making that a bit more acceptable.
Well, we try not to be too family because that gets a bit weird. Because I mean, many families are pretty damn toxic, but
True.
definitely there's that sense of this is. I remember we were working with somebody some years back, and he said, you guys are much more like a company than a business. And we stared at him, and he said, like a theatre company.
Oh, right.
Interesting. And we thought about it for a bit and said, yeah, I see what you mean. I see what you mean because it's a team that works together and works on various things and does various stuff, is very, very good at doing some stuff and probably not other things. And yeah, it felt like an interesting, an alternate use of the word company. Then someone else said, or maybe a mercenary company. And we thought about that and looked at our kind of medieval history and went, yeah, maybe, but maybe not so many deaths.
So yeah, okay. Can we just so bring it back to the employee ownership? I'm really curious. Did you really notice like a tangible change of culture and an incentive there? Because I know you said it is possible that there might be an upside in the future, but it's mainly just kind of it's almost like a respect thing, right? And I think it's the principle behind any sort of ESOP. But when you take it a step further, you're kind of putting people on an even higher level, and it's like a what does that dynamic feel like?
I think so. It means it's easier for people to see why they should be thinking about the long term.
Hmm.
Yeah, it's quite easy to come in and only think about what's happening now. What am I going to do this month? What am I going to do the next few months? But when we sit down and we discuss the vision and the strategy and the who we are and what we do, it's different if you own a piece of that rather than just you're being told by your boss that this is the vision and the strategy and that this is who we are and what we do. And so there's a definite engagement, and it's always quite nice when people get shares because there's always this like, I'm no longer a hireling, I'm now a part owner. Nothing else has changed
Mm.
except that thing. Some of my shares are vested, and so I own a piece of this. And it doesn't need to not necessarily a very big piece, but it's a piece, and it will grow over time. So I think there is something there about giving people that sense of being part of something.
And it adds a little bit more depth to decision making as well. And I'll try and bring in a no personal analogy of this. So I know from experience a few internships that I had done in the past, I was fully expecting them to be, maybe paid or at least just like not even unpaid in some instances. But then actually, whenever I was expecting that, whoever would be doing it with me was actually saying, no, look, I know you're not going to work well enough unless you're properly incentivized. And I think that, yeah, you're right. You have to make those incentives span over a longer time period. Otherwise, it just doesn't correlate with decision making that has that long term outlook, right?
Yeah, Yeah, and I think as well there's I mean we're hiring engineers in London, right? There are plenty of people who will pay a huge amount of money for your time as an engineer in London. And members of our team occasionally come to us and say, someone's just asked me if I want to go and head up a software team for a crypto firm. And we're like,
Mm.
and they said, and they offer me this much money for it. And so I laughed. And it's like, and that, it was an eye-wateringly large amount of money. But on the other hand, they'd be the head of a software team for a crypto firm. And like, there's
So
only
less
one
fulfilling.
reason you set up a crypto firm, and that's to make a lot of cash quickly, right?
Yeah, true.
It's not something where you go into work every day and you might be proud of the work in a technical sense, but yeah.
So yeah, I guess you had a little bit of well, I wouldn't call it unorthodox, but it's essentially it's definitely counterculture to nowadays, where everyone's like, well, maybe not everyone, it might be my little bubble, but lots of people are thinking about getting on the VC flywheel, raising a bunch of money, like having that sleepless couple of years, maybe raising some more money, and then eventually hoping to sell a company. But so knowing that and knowing that's the kind of mind virus that's inside entrepreneurship nowadays, what advice would you give to young people maybe starting out, not specifically in robotics or specifically in robotics? What do you wish you knew? And yeah, what do you think the landscape looks like now? Is it better or worse for young entrepreneurs?
An old friend of mine once said he'd read a lot of management consultancy stuff, and he realized at some point that there was a unified theme going through all of the management consultancy stuff he'd read, and that was the management consultants had never been in a competent company. Because almost by definition, why would a competent company be bringing in management consultants? Like, what are they going to add to it? What are they going to... So we thought about this for a while, and there's a great book by Simon, the pricing guy. It's called Hidden Champions of the 21st Century, and it's got a copy of it here somewhere. It's a bit German, and the language is very definitely is written by a German. But what he argues in there is that there are a lot of businesses out there who you probably have never heard of, because they are, unless you've happened to work in their particular niche, where everyone knows them and they're deeply respected because they are the best people in that niche. And those businesses are usually family-owned type businesses or owned by a trust of some sort or other. They have been around for often a very long time, and they do what they do very, very well, and they possibly grow at a gentle speed. Possibly they don't need to at all. And they function with some degree of excellence. And they have some really interesting properties, like people will go and work at them for a bit early in their career and then leave and go away and work in other industries, and then come back 10 years later and go like, hey, I think I could be quite a good manager now in your company. And I liked it when I worked there before. And now I've worked in some other places, I really like it. And I think that it's worth remembering that the entrepreneurship story that gets told a lot is being told by people who have a marketing and PR operation. And the reason they have that marketing and PR operation is they rely on a deal flow to invest in people who want to go on that journey. No one has a deal flow for setting up family-owned businesses that will run for 50 to 100 to 200 years. It's like there's no one with an interest in promoting that as a way of working, as a way of running an organization. So I think the first thing to think about is remember that there are plenty of organizations you haven't heard of. And they might be incredibly good, and they might be the best people in the world at what they do. And possibly the way to find them is to think about something else that you're interested in and go, who are the best people in that? And then go and see if they want to employ someone like you. Because you could find yourself being, you're a hi-fi buff. Maybe you go and work for the best hi-fi company in the world who've been doing it for 50 years. And I'm sure Bang & Olufsen are a fantastic company to work for. And that could be a really good path for you.
But you also, through being in that, you might suddenly start to recognize the clear characteristics of a company who's been doing this sort of medium to large scale lifestyle family owned business for a long time, and you think, I could improve that, or I can improve that.
Yeah.
And once you've been inside it, that empowers you a little bit to maybe step out.
Exactly. You understand how the machine works, and you build a network, because obviously the thing that every entrepreneur needs is a really good network. And you only build that network by going out and working with people and talking to people and finding people and engaging with people. Because that means that when you do have an idea and you go like, I wonder if this idea makes sense, you can go, I should probably ask Sue. Sue will know whether this idea makes sense technically, because you worked with her on something 5 years ago and you know that she knows that really, really well. And she remembers you. And so for a price of a cup of coffee or maybe a meal, be happy to catch up and tell you how your idea is stupid in 15 different ways that you didn't think of because you don't understand it as well as Sue does.
That's funny.
So, yeah, it's that kind of process. It's that kind of thinking. So making sure you know more people so you can have more people to test ideas with. And as you say, learning different ways to do things. So when you choose to do something, you've got more templates, you've got more plays in your playbook.
And just quickly going back to your comment on consultants, I've never understood this. Maybe it's just me, but it actually used to happen to me quite a lot on campus. There'd be consultants doing, "Come and work for us, come and work for us." I would just ask them, why could you possibly want any of us? What do we know? We're 21. We're 21. We're like 18 to 21. None of us have understand. Like, well, I didn't say this as eloquently as I'm doing now, but it's in my head. I'm thinking, I don't understand the substrate of the problems that you're asking me to solve. I don't understand the context in which they sit. You just want me to do trial and error on it. I mean, maybe it's just the understanding of like a fresh mind can see a problem better, but I don't personally agree with that.
I have a slightly cynical feeling that a significant part of it is people in their early mid-20s are very happy to be sent somewhere in the world and told you're going to live in a 6-star hotel for 3 months, working on site with these people, understanding their operation, writing it up and coming back and writing a giant presentation for it on expenses. And when you're doing that, by the way, you're going to be working 80 to 120 hours a week and you'll have no life outside the company. And that works very well for them. And they enjoy it, basically. But you burn out doing that quite quickly. And either you burn out by and you get promoted up in the organization, or you go somewhere else. And McKinsey's greatest strength is its alumni, and it has a lot of alumni because a lot of people leave. But that's the nature of it. Same's true of the Marine Corps.
Yeah.
Right?
I never thought about that. It's kind of like
there's a lot of ex-Marines out there, and the reason there's a lot of ex-Marines out there is you're not staying in that organization for a long time. You're doing your period in there, but an ex-McKinsey person is always first and foremost an ex-McKinsey person, and an ex-Marine is also first and foremost an ex.
And both of those people are going to struggle. Oh, it's not even a struggle. They'll enjoy having their sort of ego nourished when their old firm reaches out and says, "Oh, can you help us with this?" Now that you've gone into this thing, I never thought about that. That's great.
And also, the McKinsey alumni will go and end up in a management role somewhere else, and then they'll be like, "Oh, we need some help with this problem. Let's get my old friends McKinsey in because I know." And I'm not saying that they don't know what they do. It's just that means that you as an organization don't have those skills internally, and it's the buy versus build dilemma, effectively.
Sure. I think let's do penultimate question because we're coming up on time. So I'm just thinking now, would your younger self be proud of what you've achieved with Shadow?
My therapist talk about this a lot.
I just think it's like the reason I put that question on the list is because everyone's like, "Oh, I'm going to be happy when that salary, when this product release, when this fundraise," and it's like, take a minute just to sit and think. I think it's nice to have some gratitude for ourselves, and I think so. Yeah, that's the context, not to be a sort of interrogative therapist.
No, it's a really good question, and it's a really important question because I think it's not unreasonable to do something with a goal in mind and say, "I'm going to get to that and achieve that goal and finish that and do that," and know that the journey will be difficult and unpleasant, but you're doing it because you have a definite goal. But most of life is a process. You continue and you keep doing, and you may master the things that you're doing, but you'll keep doing them. So it's kind of important that the things you do them in a way that you enjoy them, and you do things that you do well and you enjoy, because otherwise it's going to be a pain doing it, right? It's not going to be fun. I mean, there are jobs I'm sure I could have done, and they might have had completely different rewards and completely different satisfactions and completely different challenges. As it happens, I've always quite enjoyed thinking about what could be done with technology, software, hardware, tinkering with it a bit, building it a bit, but mostly looking at it and going, where can we go with this? What can we do with it? And that's basically what I get to do in my day job. So that's kind of pretty cool. I think I was lucky enough a few years ago to get some of our robot hardware into the Science Museum. And we did a big exhibition on robots. And there's a part of the display consisted of a 7-foot tall screen with me on it talking about our robots next to two of our old robots and a couple of old Japanese robots. And I went there and I stood next to myself on this big screen talking about the robots that we built and what we'd done and how we'd done it. And my parents came down and saw it, and it was all like, it's like, yeah,
That's a win, big win.
this has been good work. This is good work. This has been a
Mm.
good process, and it's producing some good results.
Looking at all the budding future robotics enthusiasts on their little school trip and thinking, yeah,
Exactly,
this is my
exactly.
contribution.
And we do get that. We run into people who are like, yeah, 10 years ago you gave a talk at our university, and that inspired me to go and do it. Really? Wow. Okay, fantastic. And that's sometimes even more gratifying because what you've done is you've helped somebody else make a decision you didn't even know they were grappling with. You didn't know they had a problem, but simply by doing what you do and telling people about it, you can help them solve their problem.
Okay, yeah, that's a good answer. So yeah, let's for the final question, sort of a similarly philosophical question is how much does building a legacy drive the work that you do? And let's put that on a scale of 1 to 10, with 1 you're happy to be forgotten, and 10 you want to be a historical figure, you want statues, right? So I imagine you're somewhere between those two.
I always used to joke I wanted a statue that said, hero to our people, traitor to his.
Ooh, that's
Or,
good.
sorry, hero to our species, traitor to his species. But that
That's like three
required
body problem
replacing
sort of
humans with
vibes.
something else and so on. It was half a joke. But when people were like, oh, you build robots. Yeah, yeah. I mean, I think it's interesting because we are taught from an early age the great man theory of history, right? And it is the great man theory of history, very, very
Mm.
definitely.
Like the immediate meta-analysis of that. Yeah.
Exactly. It's always nice as a narrative. It's easy to remember. It makes someone look like they'll. But actually, you find that most of history is people getting on and doing stuff and building out this vast web of things that interwork and work and support each other. And actually, it's much more about mutuality and support and help. And
Mm.
I think that's where you build a legacy. There are people that you've helped. There are people who are better off, who are better than they would have been. There are people who are because you have been. And if you could do that, then you build a legacy. Statue, engraving, I don't care. As long I'm not going to be here to see it, right? It doesn't matter to me at all. I'm pretty certain that there'll be a few people who go, yeah, it would be great to have Rich now because he'd have some really interesting ideas on how we could do this, or he'd be really, and that's kind of probably where my legacy will be. There'll be people going like, that would have been a good person to have in the room when we got this problem.
Or maybe they will have you in the room. Maybe they'll have the transcript of all the podcasts you've ever done, your science museum explanation, all of the public resources of Shadow Robot, and they'll get an AI Rich.
It was slightly creepy. We had a customer come to us once, and they had done their due diligence, and they'd done basically they hadn't done the upload it into but they had found huge numbers of things where we talked in public with articles, presentations, and they've been and looked at all of them, and they kind of knew what we said we did better than we did at some level.
Wow,
Yeah, so when you talked about this and that, and I'm like, yeah, okay, that's that. Yeah, yeah. What did I mean when I said?
that's funny. So
But
yeah,
actually,
just quickly before.
so actually, just to touch on that, from a marketing perspective, that was brilliant because what they'd done was they'd sold themselves on we are the best people to work with. They'd gone and looked at all of these things that we'd done and said, and they said, yeah, these guys are great. These guys really know their stuff. These
Mm,
guys understand the problem that we have, and if they can't solve it, then we kind of know how hard it is. And if they can solve it, they're the right people to do it.
nice. I was just gonna say, I think it's in line with the quote you gave about species betrayal. I think have you seen the Three Body Problem on Netflix, the series?
I've read the book.
Sure. I mean, that's the answer that makes me feel completely humiliated. And no,
I
I should read the
read
book,
fast. I read a
but
lot.
I imagine you've also seen the scene, or it's probably a passage in the book where obviously she intercepts the incoming transmission and then she decides to betray humanity. And I just think that now I know that that might be you as well. It's a little bit, but no, I mean, yeah. Uh,
No, I mean, obviously, part of the reason I got into robotics is as a massive sci-fi geek, and I've continued that. So, yeah, I think I'm on track to read upwards of 150 books this year, which is some of them were shorter than others, and some of them were longer than others. But yeah, but I take great pleasure in reading, and I kind of it's Henry Rollins who said, the thing is, people who say, "Oh, I don't have time to read," he said that's why you don't read anything. You don't. You just you make the time. You say, "I'm going to read." I read. That's what I do. And like my first course is to pick up a book and read it. Other things come later. So that's Then you read a lot.
And just in case there's anyone out there thinking they can't, because I can definitely emphasize that as well. I mean, as a kid, I would read probably, I want to say like somewhere between 30 to 50 books a year. And I would be so nourished by books. I'd use books all the time. I'd be on holiday with books, take books to school. But then it just kind of got into my teenage years. I really couldn't get into it. Maybe something cognitive, I'm not sure. And then I later realized I had ADHD, and I couldn't focus on books for a long period of time. And that's something I never really experienced as a kid. So kind of this late blooming. But then I got into audiobooks, and I encourage someone who just can't push through with books, just really get into audiobooks, get into consuming content in a way that works for you. And don't let anyone tell you that books are better, because it's the same content. It's just in a different format.
Content. So, yeah. I mean, if there's a graphic novel of it, read the graphic novel, for God's sakes. So it's a perfectly valid form as well. I mean, my partner, similar to you, really enjoys podcasts. But I read really fast. Like, I can consume all those words very, very quickly. And can someone edit it down to tight narrative text, please, so I can enjoy consuming them? Whereas discursive conversation is its own pleasure. It's its own form of.
I actually found that as well. Well, that's the point of me running this podcast as well. I love just consuming information this way. But I actually found that I found a software that shows you one word at a time, incredibly fast. And I was reading like obscene words per minute, far more than I ever could in a book, because I was just getting the words one by one and my eyes didn't have to move.
Yeah.
And I'd love for that to become a more widely adopted sort of teleprompt reading style.
I mean, it's one of the interesting things about ebooks is, well, firstly, you can carry 50,000 of them in your pocket, which will be difficult with other books. And secondly, you can re-render them, and you can set the rendering of the book up into a form you like. So you can use. So there's some fonts that were designed to be particularly supportive for people with dyslexia. And for some people, those are really easy to read, and they help them read. I personally like a nice serif font because I just like the look of it and I like the feel of it. But the ability to change that, go to have books into terrible font, I'll change it, is fantastic, and I'll make it bigger or smaller, or I'll change the color scheme, I'll change the background, I'll render it into a form I like.
Just want to give a word of warning to people who, like me, you may have downloaded the Chrome extension which changes the fonts to Open Dyslexic. It can get you banned from certain social media websites because it actually is changing the content of the website. So I had to email LinkedIn and be like, I had no idea this was happening. I thought it would just be editing the HTML on like a client side level. Turns out it was literally like LinkedIn thought it was some sort of scrape or so, I don't know. But just a word of warning there. But I definitely think that should be something that's more. It just proves how like every time this stuff hasn't been developed enough, right? I mean,
law of unintended consequences. Yeah.
Okay, cool. Well, I think we'll wrap there before we just go on a spiral about completely irrelevant topics. But yeah, thanks, Rich. It was really nice to chat, and I will link all of Rich's socials and Shadow Robots links and information down in the description below. So anyone who wants to see that, go do so. So yeah, thank you very much.
Thank you. Have a good day.
Awesome.